Good morning, good evening, wherever you may be across the nation or around the world. Once again, you are listening to the VMware Communities Roundtable Podcast. Today is Friday. No, it's Wednesday, May 29th, 2019. John White, you're my co-host today. How's it going?
Going really well. It's the Friday broadcast that's got you all twisted around.
It is. It's great. We did a great Friday broadcast, and man, we got like 4,500 downloads on that Friday broadcast. Really, and I never updated it. So people that listened, I'm sorry. We had a moment where we had echoes and we had to stop, and I said I would edit it, but I never did. So so appreciate you guys listening to that 3-minute debug session that was right in the middle of the podcast. On the show today, we have Justin Murray. Justin is Senior Technical Marketing Architect. He's going to be talking about machine learning, AI, vSphere, the industry. We got everything. Justin, welcome to the show. You're in the studio.
Thank you, Eric. Thank you. Nice to be here.
It's nice to be here. We'll get to Justin in a little bit, but first we'll do the news, and then we'll get to our new hire that we have in the studio as well. Casey, we'll talk a minute to Casey, just to introduce him to the V community out there. But before we do that, let's do a little bit of the news. I don't have a lot of news. We obviously have the standard news we do every show now. Early bird registration opened on 05/07 for VMworld. Content catalog goes live 06/18. Early bird registration U.S. general, I think, is 06/21, and for Europe is 07/26. I don't know the differences behind those. Schedule Builder 06/16, 2019. Europe is 09/24, 2019. The conference is 08/25, 2019 for US, and the conference for Europe is 11/04, 2019. So no major dates coming up yet, but it's on its way. So be aware of that. The second bit of news that I do have is that Casey has joined the VMware team. Casey Soundarajan, welcome to the VMware Community Podcast.
Yeah, thank you for having me.
Yeah, it's nice to have you in the studio. We'll just talk a minute. What are you working on? Tell us a little bit about what you're doing over the course of leading up to VMworld.
Yeah, so we're working on a Raspberry Pi lab where we're implementing mini Kubernetes on it, and hopefully we can get it running by VMworld.
Nice, really nice. So I know there's a couple components to that you're working on. One is getting the Minikube on a Raspberry Pi. Second is maybe an application.
Yeah, exactly. So we're hoping that someone else in VMware can help us maybe develop an application and implement that and give people, I guess, something to do at home, something that's pretty easy to get started with, and a great application of Kubernetes.
Right. So by the time you're done, we'll have mini Kubernetes running on your own Raspberry Pi, so you can do a quick $40 Kubernetes implementation at home. Easy to do. And then Tim Davis has built a nice app, and we're going to try to trim that app down so that it'll run on a Minikube. Right, so that's our goal, and then finally using IoT sensors to pull data from the sensors into the Raspberry Pi into your Kubernetes application, and then finally the last bit. What's the last bit?
Trying to put that all in the cloud and get that running on Amazon servers as well, I think. Yeah.
Right. So using
hybridity.
Yeah, PKS out so that now you have a payload, you have an application running on your Raspberry Pi, being able to upload that to PKS. So that's what you're doing over the next several months, and hopefully we'll get it running. We're going to take it up to Developer World in New York in 3 weeks. So he's got 3 weeks to at least get some part of it running.
Timeline.
Yeah, and then once we get it debugged, we'll bring it to VMworld. So,
very cool.
Casey, it's great to have you on the team as always. So thanks for joining us in studio. Mostly you'll probably just listen to us, but feel free to jump in as we go along.
I do have a little bit of news. There's a GA of the latest version of Cloud Foundation. I think the main payload was the security update for vSphere that came out. So I think it's hotfix 9, 6.7, hotfix 9 is part of the Cloud Foundation payload now. And then I have the British Columbia Regional VMUG UserCon is on June 4th. So if you are thinking about going to that, make sure that you're registered up. It's Vancouver, June 4th. 8 a.m. to 6 p.m.
A UserCon coming up. Great. We should do a shout out to all the people on Facebook. Hey guys, how's it going? We got cameras on both angles, so it's always fun to see how many people watch us live stream and actually recognize us and say hello. So good of you guys to give us those views. We appreciate it. All right, Corey, you're on the call. Got any vExpert news coming up?
Yeah, I do. Hey, welcome, Casey. I'm on the team as well, and I'll meet you tomorrow afternoon So looking forward to it. vExpert News. So this morning we had a meeting with Cloud Foundation, and the topic was Cloud Foundation and Lab Constructor. We also sent out a doc for nested Cloud Foundation deployments. So vExperts, go and check your mail. Very, very cool and interesting meeting and webinar we had this morning. We also are planning the VMworld US party. We don't have a location nailed down yet, but we have a few that we're looking at. So we should have an announcement coming up in the next month or two on what that party will look like, and the sign-up form and email like we normally do. We also will have the next 2 weeks a sub-program announcement, so that will be coming. I don't want to say what it is yet, but looking forward to that announcement. I've been working with some folks in VMware, and it's a really, really cool program for the sub-programs that we're developing.
I got one follow-up question on that, which is if you're going to do sub-programs, are we going to ever get the sub-programs in the vExpert app?
Yeah, they're in there now, so you can apply in the vExpert app. We don't have the capability of doing voting in the app yet, but by the time we have voting for this new sub-program, it will be implemented into the app.
Nice. Sweet. All right. And before we kick into the main topic with Justin, I got to ask, Color of the Bay. We skipped over it. I'm sorry.
Color of the Bay report, absolutely. So it was kind of a green with some muddy upwellings as I crossed the San Mateo Bridge today. It's kind of crazy. I don't exactly understand the weather. It's a hazy day. I don't know if that adds to it. Maybe it's the wind. But yeah, I just still, it's
almost getting summer.
Yeah.
You're kind of crossing over back from winterland again. It was snowing across the U.S. We got it. We got a lot of rain, but now it's 75 and it's supposed to be good this week. So again, odd weather.
I'm wearing an overcoat, a pullover, because I had no idea what the weather was going to be like. 3.5 years in the Bay. I still don't get it.
And if you're listening to this and wondering why we're doing the Color of the Bay, it's a throwback to my favorite original podcast that inspired me to do these with John Troyer, which was the Hawaii Surf Report. And this Hawaii Surf Report was just this report, and all they did was just go around the island and talk about the conditions at each of it. And they did an hour podcast, and I love that. I don't surf. I've never been to Hawaii, but I just love the idea that they gave you a sense of what was actually happening in Hawaii. So we threw that in as, hey, the Color of the Bay.
Yeah, so the story that I tell myself is that the very first time that I was on the podcast, I just decided to do it, and you looked at me like, what are you doing? And then we never talked about it ever again.
It could have been that. I'd go with either story. This sounds good. And moving on from the Color of the Bay, Justin Murray, Senior Technical Marketing Architect, here to talk about machine learning, AI, and everything that we need to know about it. So Justin, welcome to the show. Why don't you tell us a little bit about who you are and how long have you been at VMware?
Thank you, Eric. I've been at VMware since 2007, so I'm an old guy now. I've been here 12 years. Doing a variety of different jobs, but about 4 or 5 years ago, customers were asking us, how do we do big data on VMware? And I got involved in that and Hadoop. And customers are still asking us that to this day. It's amazing. I think what we're seeing is they went with physical and they're coming back. And gradually, what my team and I noticed was the questions are now evolving into machine learning. And so about 2 years ago, we started playing around with Spark on VMware. Spark is open source. Anybody can download it. It takes about 10 minutes to install it. And I got fascinated by this. And what I've learned from this machine learning stuff is all the math I did at college that I wasn't sure how I was going to apply it.
Right.
Here it comes. At last, it's relevant. I wish I'd paid attention to my statistics now.
That's fascinating.
Regression.
I have to throw back a little bit. When I started here in late 2006, 2007, right about when you did it. You were crawling the halls. We were crawling the halls. We didn't have this beautiful campus. We were over on Porter, I think it was.
Right.
And in the old wooden creaky building, I call it the Harry Potter Castle, because it had little hallways and wooden steps and everything. And I think you came from HP and I came from Sun Microsystems. Right. And we showed up at this little tiny company that was making waves around virtualization, and we looked at each other and we went, we don't know if we're too old for this or not. We come from Sun and HP and but here we are, and I bump into you every once in a while through the halls, and we nod and we say hello.
Absolutely.
And then I scheduled you on the podcast, not knowing you were you. So when you showed up in the room, I'm like, oh my God, it's Justin, the guy I always say hello to. And here you are, and working on some pretty cool stuff. So all right, great. That's your history. Really, really fun. My son goes to CMU, does neural networks and AI, and I would say that the math is a big deal now, right? And he is, man, they do heavy duty math to do that stuff.
There is a lot of math involved, and it makes it exciting. It's interesting because you can apply this. And what your son is doing is the sort of neural network end of machine learning, which is the stuff that everybody's talking about, the most exciting stuff around.
Right.
But it's not the only kind. You can do machine learning on your boring relational tabular data, on your CSV data in Excel spreadsheets. You can do machine learning there. And that's, I think, the key message is there are at least two forms of this. There's the high-end form, which is GPUs and neural networks. All of that works on VMware, by the way. And then there's the form that we started off on 2 years ago, which is just take rows and columns of data and try to do predictions of credit card defaults, for example.
Right.
And banks and insurance companies and every company is full of sales data that's in table form. So why not start there? It's a very practical way to start out. And there's no neural networks involved. There's no GPUs involved.
That is actually really interesting. And that's the way I tend to approach things. Like, what can you do with a pencil and paper?
Right.
With just raw data,
Right.
Instead of getting super fancy and trying to make a human brain that's like, can we just do predictive analysis or some kind of here's the rows, here's the data. I have a CRISPR lab at home. I do a little bioengineering, for fun. It's kind of my hobby, and the medical bioengineering stuff. And if you just look at the practical approach of looking at big data and just making some predictions, just not very complicated science, but just looking at just the raw data and trying to say, what's actually happening here, and can we just do some simple learning around the data sets?
And you bring up a great theme here, which is, what does machine learning need? It needs pretty massive quantities of data for training its models. So that's where the world of big data and the world of machine learning come together. That is, Hadoop and all those things for big data. They've found a real use now. And you're seeing companies who made their living out of Hadoop shifting very rapidly to becoming machine learning companies because they've got the data.
Right.
They've been storing it in these big repositories. They've been really talking about the past. They've been doing SQL queries on this data using, Impala, Hive, and all that. But now it gets more exciting because they can talk about the future. They can predict what's going to happen next. And, fault analysis in banks is a classic application for this.
Right. So let's quantify these two forms again. The first form, tell me about that. The second form I get, rows of data, data analytics. What was the first form?
The simpler form is the tabular data. I call it tabular data. The second form, the more sophisticated form of machine learning, and the kind that everybody's paying attention to, I would call image, voice, and text data. So you can ask a data scientist in your company, what are we using for our training data? Are we using data in tables with rows and columns, or are we using images of cars or stop signs if we're in Tesla, for example? Or are we using voice, or are we using text? And those last three, images, voice, and text, require a little more machinery and a little more sophistication than the tabular form does.
The Tesla
But
AI,
every company's got tables. Every company's got spreadsheets and relational databases. So this is very, very common, and you can apply the same principles to it. And curiously enough, applying that heavy-duty machinery, GPUs really support neural networks, because neural networks are doing thousands of mathematical calculations per second, or billions of them per second. And that's why GPUs are really popular, and why NVIDIA is really popular. But that's not really applicable when you're talking about rows and columns of data. You're multiplying a row by a column to get a matrix multiplication done, and that's it. And
you don't need a GPU for that.
You might get 5% extra with a GPU, but you don't essentially need it. So that's a good message in the sense that you can get started, as we got started in our lab here in technical marketing. You can get started on that kind of data and learn a lot that way if you're just starting out in this.
You probably already have the data, and you don't need any specialized hardware to get started. And you probably don't need to acquire any hardware if you do this all on your existing vSphere lab.
Exactly. I did my first machine learning 2 years ago on standard x86 machines, on vSphere, standard VMs, nothing special about the VMs. Now today I'm in the world of assigning a GPU to a VM and running a neural network like TensorFlow generated neural networks on it. So things are changing, and you go back and forth between the two. But getting started, you can get started with no special hardware, as you rightly said.
Right.
What are the ISVs doing in this space? Who are the big players, and what are they attempting to do here?
Very, very good, very good. And I'm going to describe Google as an ISV to begin with. That's probably the first person ever to describe them as an ISV. But,
Right.
that's a huge innovation engine there. And they've done two things over the past couple of years that really stand out. One is Kubernetes, which we've been mentioning. And
Sure.
I've been deploying machine learning models into Kubernetes in the past few days. And it's fantastic stuff, And the second is TensorFlow.
Right.
And TensorFlow is really designed to make neural networks easier, to make the creation of them straightforward, really to democratize the programming that's required for artificial intelligence and machine learning. And I'm going to make a slight differentiation between those two. I think AI is a huge field, very broad, and I would say it's any technique that enables computers to mimic human behavior.
Okay.
Now, human behavior is very wide. It's not just learning. It's judgment, it's reasoning, it's decision making. Machine learning is just a tiny subset of that.
Okay.
And
Right.
we're a long way from being able to replicate a human's intelligence, really. But the machine learning part is a bit like your child learning at 2 what's good behavior and what's bad behavior. And the good behavior and bad behavior is the labels that are on your data. That's the training data that you feed to the child. The child is the computer program, the machine learning algorithm, the neural network. You're feeding it these historical records of good and bad behavior. And you're saying, now in the future, when something new happens to you, I want you to be able to classify it as good or bad.
Right.
And you're giving it more and more experiences all the time. And the fascinating thing about this is the training that you've given needs to be constantly refreshed. It's never going to sort of stay the same forever. There are new experiences that you've never met before that you need to supply to the training phase as you go ahead. So it's a bit like software development, training these models. It's applying the model to the training data, have it go into the real world and do something, and then come back and retrain it again and again. And so you're constantly delivering. So it's a job for life for these data scientist folks.
Sure.
Continuous integration model, same thing. So
Exactly,
software development.
a CI
Right,
model,
right,
exactly.
Right.
And then within the machine learning definition, there's another subset, which is that form of machine learning, particularly that uses neural networks. And neural networks are another form of machine learning model, a sophisticated form. And they've got thousands or millions of nodes in them, and each one of those nodes is doing matrix multiplication. So that's where the billions of transactions go on. And to support all that, that's where the GPUs come in. So I would say that's really deep learning, where you're using deeply layered neural networks. That's where GPUs really shine and give you the boost and amazing
math.
boost in performance.
Yeah. Okay, that makes sense. And we talked a little bit about the platforms. What are the applications that are starting to bubble up from this? There's business applications that are starting to see benefits from these machine learning environments. Can you talk a little bit about that?
There's a wide variety of applications out there, but the classic one that everybody quotes is fraud detection in banking or insurance or
I hate
risk assessment.
They just bother me.
Is this person a good bet for a credit card?
Right.
Right. This person has just applied for a credit card. Well, what's the person's zip code? What's their history of transactions in the past? What's their annual salary? They'll ask you these questions. And of course, what they're doing is applying that to the already trained model, which recognizes the weight of all those things and says, this is a good bet or this is a bad bet. So that's well understood and that's out there and people are in production with that. Insurance companies, same idea, risk management. But getting more exciting than that is recommendation engines. You've bought these 3 books in the past. You're going to be interested in this.
We're getting in that in digital marketing now.
Right.
We're using that kind of stuff.
In VMware's own products, what is standard behavior over the past 6 months of this set of machines? And what is deviant behavior? What is wrong behavior? What is overheating of something in the machine? And so prediction that if you run this database at this 90% level for a week on end, you're going to
cook something.
You're going to stress something out.
Right.
That sort of prediction. And so VMware is applying this idea of machine learning in 3 different ways. One is put it into our own products, and that's important because our products can benefit from it and be more sophisticated. Be a great platform for customers to do machine learning on. In other words, if you're going to run
different strategy, but okay.
If you're going to run Spark,
right,
and improve customers' business,
right,
is the third one. So there's 3 kind of legs to the stool there.
Right. So 1 in our products, right. 2, making sure that AI and machine learning runs well on our products, and then 3.
Improve the customer's business. Help the customer.
How do we get into that?
Well, in general, the advice to a customer is try this out on more than one thing at a time, because you're not always guaranteed success when you start on a machine learning project. Right. So run 3 or 4 projects together and do a sort of horse race between them as to which is going to give you the main benefit, and do something that affects the business.
Okay, I
see. There's a tendency with this technology and the more advanced form, GPUs and neural networks, to just fall in love with the technology and want to do something with it. But what's the business reason? What's the business value?
Try to help them understand. Do we have experience in this to help guide customers?
Yes, we do. Yes, we do. We've talked to quite a few customers about it. We've done. For the second goal, which is to make ourselves a great platform for doing it on, we've tested TensorFlow, we've tested Spark, we've tested, third-party companies that you may or may not have heard of, like H2O.ai and K9 or Nime and RapidMiner, companies that supply the tools into this business, and they all work great on vSphere. And surprise, surprise, if you put a GPU on a vSphere machine, you'll see about a 3%. 4% performance difference.
Okay,
what you would have seen in physical. Right. And if your training took 2 hours, it'll take 2 hours and 5 minutes. It's not. Right. It's not a huge amount. So that's a good message to give out to people, that you can do the more sophisticated end of machine learning, GPUs and neural networks
on your current IT infrastructure.
On your current VMware infrastructure, and we'll show you how to dedicate a GPU to a VM, or dedicate more than one GPU to a VM if you want to.
I understand that you're in technical marketing now. Where are we as far as actually being able to spin up maybe like a consulting practice to actually go into a company and say, hey, you're doing this, whether or not you're using vSphere, we have found a lot of success on that. This is how we do it. Here's maybe some great architectural examples and data sources and use cases that we found. More success if you're looking at your sales data. More success when you're looking at your delivery data. Those types of things. Is that something that we're doing?
There are some folks inside the company who do that. Yeah, and we get called into such customers a lot from the headquarters, if you like. But there are some field folks out there in the PSO and the professional services who can have that conversation with the customer. Data scientists are hard to find. They're being trained at college right now, but they're not out there with industry experience yet. So getting the right team of people in the room to identify the projects and identify what exactly the technology is that you should apply to those problems, we can help with. Yes, it's a rare find, actually. It's more and more people are going to come out of college with those skills, but it's pretty rare. I wouldn't say that we have a mature consulting service in that area yet, but we certainly have people who can give advice and help.
Got it. And are there other organizations out there? Is it like the big 5 consulting companies? Is it like, who actually does have those machine learning practices?
I would say typically it's the ISV that you commit to. If you commit to a company like Databricks or Cloudera or Hortonworks, and Cloudera and Hortonworks have merged now, so they're the same company, or a company like H2O.ai that have dozens of data scientists working for them, or the big 5, as you say, or the big 4. We've seen those folks at the
conferences,
machine learning conferences, and they're all over it. It's a complex subject. There's lots of choices to make as to which model and which parameters to tune in that model. There's a lot of decision making, but there's an interesting move in the industry to democratize it, to supply enough tooling such that you hand it your training data in a file, and the tool actually does the rest. Does the choice of model, does the choice of hyperparameters, which are the tuning
interesting.
parameters.
Right.
It's
Can you apply AI to the data model to then develop the machine learning structure you need to harness that data?
That's exactly the theme here. Well described, which is, given that you could choose any of these 10 models, what does your previous history tell you about applying a particular model to a particular data set? So, for example, tabular data, the simplest form, it might be the case that models like XGBoost, which are very popular and trendy out there, do the job 90% of the time. So try that first.
Right.
Or,
Sure.
A deep neural network like a recurrent neural network, an RNN, is best for handwriting recognition or voice recognition. That sort of best practice is emerging now.
All right.
And being coded.
Since most of the guys that are listening to this, or folks that are listening to this, I won't even say guys, everyone, the audience members, are IT practitioners, which is who we talk to. Bring it back to some hardware choices, right, and architectural choices. Are there things in these three different layers what we are giving you to run a machine learning versus taking up that next layer, which is how are you using it versus business solutions? What are the kind of hardware architectural issues that you have to look at when you're considering building out infrastructure for your own AI projects in your company?
Right. That's a great question, Eric. Thank you.
That's because it's on my list that you gave me. I mean, come on, we're just going to be real here.
Give you that question?
Yeah,
No.
maybe you did, but it is a great question. So continue on.
First, let's break machine learning down into two main phases.
Right.
There's the training phase, which is the application of the historical data to the model and getting the model to understand its weights. And it adjusts the weights on the fly, and there's thousands of these transactions going on. So that's computationally intensive.
Okay.
Right? That's going to drive your CPU up to 90% or above. And if it's a neural network you're using, you're almost certainly in need of a GPU, and your data scientist is saying, I need a GPU here. This thing is taking 5 days to train. I need to bring it down to an hour.
Right.
So the question we get the most, and there's almost a sort of deep connection in our customers' minds, is, I want to do machine learning. Tell me about GPUs. That's the infrastructure question that comes up immediately.
Right.
And then the second phase of machine learning is called inference, prediction, classification. That's the production part, like productizing a software object. Mm-hmm. And what you've done is you've taken your trained model from training time and delivered it as a end goal deliverable. Right. And the question is, what am I going to deliver it into? Am I going to have another virtual machine that looks exactly like the training one?
How big do I have to scale it?
Or could I use a Raspberry Pi for this if it's on a factory floor, like Casey's going to do? So inference is often associated with lighter weight compute technology, the edge.
Okay.
Doing inference at the edge. If you're on the factory floor, you want to know if a sensor is going to blow in an hour's time.
Right.
So we, in my unit here, the vSphere unit, very much focus on what do you need to make training more efficient and faster. And generally that's big memory, and it's very often, when you're talking about neural networks, as everybody is, a GPU, one or more. And we have 3 or 4 different techniques of implementing that on vSphere. So there's pass-through, which is effectively saying, hypervisor, stay out of the way here. This is a CUDA command that I'm issuing to the GPU on my machine. Stay out of the way and just pass this through direct through the hypervisor to the hardware.
Right.
And these are all based on NVIDIA drivers, etc.
Okay.
There's a second technique which uses NVIDIA Grid, which is a piece of software you can buy from NVIDIA. It's licensed software. It's got a longer name, Quadro Virtual Workstation. But that software allows you to share a GPU among 2 or more users, which is fantastically interesting.
That's neat. Yeah.
And then there is a third form, which is, I'm sitting on a CPU-based VM, and I want to use that GPU over on the other side of my data center that happens to have GPUs associated with it.
Right.
Could I do that across the network? And BitFusion FlexDirect is a software.
Yeah, they always show that demo at VMworlds where they're doing that trick, and it's super cool.
It's amazing because all of these folks can be clients, and they can use remote GPUs, and they don't have to own them.
They're all playing video games, and they talk about how that all this is being rendered on this remote bank of GPUs.
Yeah, and
so that third instance.
I went to a talk by some serious data scientists from Facebook a couple of weeks back, and their big thing was, how do we know that the GPU is really being used to the extent that it could be? How do we know that it's well utilized?
Right.
And it's amazing the engineering they built using NVIDIA tools and using their own engineering technology just to figure out where the bottlenecks are and why is this GPU not being used to 80 or 90% capacity. And I think that tells you that even though we have frameworks around TensorFlow, Keras, etc., people are still not confident that they're getting the best value out of these. And so sharing GPUs is not an outrageous proposition by any means to give to many customers to say, you have a team of data scientists doing X project and a team of data scientists doing Y project. Do they really need a GPU dedicated to their virtual machine?
Right, or a bank of GPUs. Yeah, exactly.
Some do. And some very high-end data science training jobs need 4 GPUs, and you're seeing NVIDIA ship machines with 8 or 16 GPUs in them.
Right.
But you really want to test that out early on if you're an IT person. Just how much utilization are you actually using?
Yeah, I'll throw the instance in here. My son, again, is actually interning at Facebook this summer, right? And one of his projects was obviously, a final project for his junior year where they needed, it was taking, I think, in 15 minutes to come up with the answers they needed through their algorithms. And they had it on their own, hardware in the data center. They eventually then got permission to go to AWS and get big, neural network GPUs, assigned to the project, and they got it down to like 12 seconds, right? So, you can actually then go to cloud and get even additional GPU resources assigned and run your workload out there too.
And that's a theme we've been exploring in the labs here, which is that is training best done on premises and inference done in the cloud, or is training best done in the cloud and inference on premises? And you can imagine that you don't really want to do big training jobs on a factory floor. You want to do it somewhere you've got serious computers. Right. And that might be in the cloud, and we've done it on VMware Cloud and AWS actually, and use the the Spark platform in both places. Very lightweight platform.
I want to know when the belt is going to fall off the factory floor, when the jive chain is going to jump the track, right?
So as to get out of the way as quickly as possible. Yeah. That's where machine learning becomes vital there. Yeah.
So maybe I just want to make sure that I'm understanding this correctly. The training is the heavyweight part.
Yeah.
And so that's when you're building the black box, so to speak.
That's right.
Right. But once that black box is built, the idea is that you can run that on a lightweight platform.
Right.
Okay.
Lighter weight than the training platform,
Got
yes.
it.
Yeah. So it could be extremely lightweight. We have a performance engineering gentleman that works with me here in VMware who took training that he'd done on several VMs, like half a dozen VMs, trained his model up, and then delivered that into an IoT style box, a very small box that could be sitting in the point of sale at a grocery store or factory floor. And the idea is that this thing can spread out to many different devices and then feed its data back to the factory later on when it's quiet, so retraining can be done on the model then. So yes, training is the heavier part of it.
Got it. Okay.
Yeah.
Nice. Let's see. Is there one growth in one particular industry? Is the growth in one particular industry? Sorry, just reading this. I type fast. I guess, are there industries that are, ahead of the game? Obviously, self-driving cars and health and medical and risk management are clearly forefronts in this space. Where do you see other industries jumping in? Do you hear some interesting places where this is growing?
Yeah, I'm fascinated by the application that you mentioned, which is new drug research and, looking for patterns in historical. Do we really have to go through all these trials every time?
Right.
So can we derive something from historical data that shows us the pattern to go after?
Well, and actually, if and this, I'll just go here for a second,
right?
Because it's it's hobby, but it's not relevant. Is that all medical research is actually black box research? We don't know actually what's happening when we introduce chemicals, right? We can't see small enough to know so all we can do is do one thing and watch the results, right? Well, that's perfect for machine learning, right?
Yeah.
Because that's all trials are, is we gave you this pill and we watched and we recorded X amount of data to see, did you die, did you this, did you sweat, all the things that happen, and we categorize that. And so actual medical research is a very slow version of machine learning, right?
Yeah.
Right.
Yeah.
So, yeah.
And very large healthcare companies are applying these techniques to do, analysis of health trends, but also analysis of side effects of drugs, etc., and doing research there. And I think that's an amazing field to apply to. The finance companies have a lot invested here because I would say they're probably the most aggressive adopters of this because the use cases are clear. Fraud was a big one. Risk management is another one. They're definitely spending on this business and looking at the tool vendors and saying, what can you give me to make this a democratized study? I don't want to have 50 PhDs in statistics working on this. I want every programmer to be able to do this, and then I think automotive is definitely a huge field because we're all looking forward to autonomous vehicles.
Yeah. Yep.
We hope the autonomous vehicle recognizes the stop sign and
doesn't kill us.
And it needs some heavy duty training to do that. And the inference then is taking the model from the place where training is done and putting it in the computer in the car. So that has to be compact.
Right.
And you can think of that model as a set of coefficients, a set of weightings that says, the color's red, the letter is S, it's probably stop sign.
Right. So benefits of doing machine learning on VMware, if we just want to touch base on, obviously we have all the physical to virtual benefits of running vSphere and ESXi on hardware and getting that utilization. Other benefits?
One of the huge things that I see is that I've dealt with a couple of ISVs in the past 6 months or so now, and you see a new version of their product every month. So I'm using 1.3, 1.5, and 1.6 of a product a very interesting product from H2O called Driverless AI, democratizing AI. But how do you cope with that rate of change? And TensorFlow is changing at the same rate, and everything is changing at the same rate. So you have a set of well-paid data scientists. You want to keep them on the tools that they want to be on, and they want to be on the latest.
How do you tame the cats here?
But at the same time, the product that we have shipping today was version 1.1, and we need to be able to recreate that.
Right.
Well, that's perfect for virtual machines. And you want to isolate these people from each other such that the behavior of TensorFlow on VMs 1 to 10 is not affecting the behavior of XGBoost on 11 to 20. So performance isolation, which you don't get from containers, and I'm becoming a big fan of containers, and containers are in my machine learning lab now, running in VMs. But containers don't give you performance isolation in that sense, and they don't give you version isolation to the same extent. So deploy your model in a container. Been doing that over the past few weeks here, and then have that container managed by Kubernetes because you're going to need replicas of it.
Yep.
But the virtual machines come in at the infrastructure level because of the separation and because of, you can think of a virtual machine as a collection of containers that belong together, a pod in Kubernetes terms. You can think of a virtual machine as that unit of containers that all start and all end together. And so the two match up very well, and there's no sort of impedance mismatch between these two technologies as far as I'm concerned. But the second reason, which is kind of a crazy reason, is not so crazy. All of the customers that come in to me have already got thousands of VMs around, and they know how to manage them.
They know how to manage them. You can get them. They're part of the process.
And it's almost a standard operating procedure now. If anything needs to be run as an application, it runs on VMware.
Right.
And my job really is to say, this machine learning stuff is no different. You can run this on VMware, and it doesn't impact your performance and gives you benefits in isolation and that sort of thing.
And I would say that I'm kind of a cowboy when it comes to IT resources, and I spin things up. I've got things in Amazon AWS. I've got Elastic Compute resources. I run things on Raspberry Pi. But what I would say is that after a year or two of this, I'm tired, and I want to consolidate it, and I want to have it somewhere where it's just supported by my IT staff. Right?
My first experience was running something on the public cloud and being charged for a month's use. To my surprise, I didn't realize I had to shut this thing down. And I feel safer on premises in some respects.
And I think it's really great. I like the speed at which I can do things on AWS. But then I've got 10 things running over there now. Now applications, vExpert apps, Cloud Cred, other things that we're running. And now I'm realizing that I have to become an adult here, right? And
Well, you
and,
also-
and so it's good to be able to plug that back into a vSphere.
Right. And I've taken Spark-based applications that are running machine learning, running
Right.
linear regression, and moved them onto Spark running on VMware Cloud and AWS. But the training data that they're using is coming from S3. That is, I can cross that boundary into native AWS services. I can even use ML algorithms that happen to be good over there and get my trained model back into VMware land and run it there. So the boundaries are blurring between these. When the deliverable is quite a small thing, it's a model. It's not a whole software architecture. It makes it easier.
Just to blur the boundaries and more, we announced our intent to acquire Bitnami last week. Bitnami has they have TensorFlow, ResNet, Inception, and Serving
Right.
on their platform. You can get those as OVAs or as containers. So if you're an IT professional out there and you suspect that that's one of the things that you need to do to remain relevant as a department or as an individual, then getting those OVAs, playing around with them, and saying it's one of the things that you can do again to remain relevant. Hey, if you guys have a TensorFlow project that's coming up, we can help deliver that within the IT group, and then you're staying relevant to the business.
And just a remark on that, John, that notice in that terminology, we've got TensorFlow, which is a programming platform, and ResNet and ImageNet, which are pre-trained models, right? The deliverables have changed.
Right.
It's instead of saying, I'm giving you the tooling to do your programming, I'm giving you models that have already been trained and developed and are already quite mature and well tested.
Kind of like application as a service. It's machine learning as a service in a module.
And those models were exactly what the performance engineering guys here tested on to make sure that VMware is the right platform for this. They tested exactly ResNet and ImageNet, and there are white papers on this available from VMware.com that you can get a hold of and read, and they're full of good science. They've got good performance tests there, but that's very interesting. I'm looking forward to talking to those guys.
What are the pitfalls and best practices around machine learning? Where do you see the biggest mistakes?
I probably haven't enough time with the industry to say what the real mistakes are yet, but my guesses, just guessing at it, is I think not doing a variety of projects to start with, focusing in on one
Just
project
betting everything
and betting
on this one idea that we had.
betting everything on this one thing, and not even getting started, saying this is too much technology for me, I couldn't possibly do this. This is being democratized very quickly now, and Justin has had no training in data science, but I'm using a tool that enables me to behave like a data scientist.
So overscoping to begin with.
Overscoping
right? And a single instance.
and
of
then being
something.
too fearful to get started. I think get going on something now, and choose 2 or 3 relevant business use cases that will have some value to your business, rather than a science experiment. And it's
interesting.
In a sense, it's similar to the Hadoop history, where people love the technology, but didn't identify the business use cases that would have most effect on their business to apply it to first.
Mm-hmm. So most people work in a business with a sales department, right? So if you're an IT professional, do you think that you could go to some kind of like sales analysis department and ask them, hey, do you have a project like this? Would you be willing to partner? Maybe that's a place to
That's
start.
perfect. That's perfect. Yeah. In fact, somebody asked me earlier this week, can we do a propensity to buy model? And my answer back was, give me the training data with the labels on it, and we'll put it into the tool and try a model. So try something out like that.
Right.
But that's a clear business benefit. Everybody's got sales data. Everybody's got their market data. That's a good place to start.
Nice.
Yeah.
Yeah, that leads us into the final one before we ask where you're going to be throughout 2019. But we'll do that. Like, how do people get started with vSphere? Like, what are the kind of steps that we should tell people to go play with?
We've written a whole bunch of guidance material. So if you go to blogs.vmware.com/apps,
/apps. Okay. Blogs.vmware.
blogs.vmware.com/apps. So that's not just machine learning. That's SAP advice, Oracle advice, Microsoft advice,
right.
and there's a section there on machine learning and high performance computing. And we make that distinction that high performance computing is the science workloads, the university research departments doing research, and I've got colleagues working in that area that are writing about that every day, and I'm writing a lot of blogs and articles about the subject of ML. So blogs.vmware.com/apps, and if you want to go further, /apps/ML, and that will that will give you.
That'll be you. That'll be
me.
your stuff.
And you'll find a series of 4 articles there that go into great detail about what the choices are for GPUs and how to implement them, for example. So it says, first of all, decide whether your data scientist is getting a GPU unto himself or herself or not, or whether he or she needs 2, or whether they're sharing. And sharing is a kind of a safe place to start. Right. And then there are different methods to go forward with each of those, and there are details there about how to do that. And I find it very interesting to read the performance papers. That's where the best practices come, really, and that's good news. It's 3 to 4% that you're going to be looking at worst.
Correct. It's interesting that you say start with sharing. I mean, that's kind of like the VMware like mantra, right? Like share everything to start with.
Exactly.
And then the point where people are demanding dedicated resources, that means that your project has been successful.
Right. You're doing serious work now.
Yeah.
If you're occupying a GPU fully, if you're occupying 2 GPUs fully with your training job, that's a serious machine learning application. That's a high-end application. But you're right. We're interested also in the sharing, folks, and a lot of our customers are saying, "Tell me how I can share it." And ironically, it's called a vGPU, virtual GPU. It's a software object that represents the hardware GPU, but is really just a part of it. It's 1/8 of its memory, or 1/4 of its memory, or something like that.
That's what is kind of what Grid is all about. Is
exactly
representing. Well, you have a 16-core GPU, but really what I want to do is represent it as 16 1-core GPUs, or
particularly memory.
Yeah.
The memory of the GPU is carved up into equal slices at the moment. They could be unequal in the future, and so 16 gigs of memory. Give each virtual machine 4 gigs of that memory, and suddenly you're sharing the memory of the GPU, you're sharing the device.
Oh, okay.
So that's a sort of one-liner on the NVIDIA Grid software, which goes into the hypervisor. There's a driver, a VIB install in the hypervisor, and then there's a driver at the guest operating system, and they communicate to share the physical GPU. And we've tested that, and there's no performance impact of any significance there as well.
Nice.
So
it is 2019. Are there conferences that people go hang out in when you're talking machine learning? Do you get to go to any of these guys? Do you ever do any papers?
Yeah, there's at least one ML conference a week, I think. It's amazing. This is a hot subject. There's a lot of buzz around this, but the ones that I like, I've been to this year are the Spark Summit.
Okay.
The Spark folks, Databricks, are working hard on tooling for democratizing again, the workbenches, basically. Cloudera is working on workbenches. H2O's got a workbench. This must be a hot area in the market because everybody's taking their previously data repository type thing and making it now a machine learning workbench. There are several. There's a conference called NIPS, which is neural. The first word is neural, and that I think that takes place in the springtime. It's over for this year.
Right.
Well, that's a or NeurIPS, I think it's called. There are several machine learning conferences around.
Right. So you can just go Google them, find them, but those are the kind of ones that you've been to.
Yeah, I like the O'Reilly Strata Data Conference. It happens twice a year, once in San Jose, once in New York. That's a good one. That gets
interesting. Okay.
There's even a TensorFlow dedicated O'Reilly. I think it's called TensorFlow World. They've just designed it.
Yep.
They've just designed it. So
makes sense.
Everybody wants to learn as much as they can quickly here.
And then, do we do anything at VMworld? Are you gonna do a paper or get a talk?
Yes. Everybody's fighting with me to get these slots here. So I think there are going to be at least half a dozen to a dozen talks on machine learning at VMworld.
Wow.
There were last year.
Interesting.
Outside.
I didn't know they let you talk. I didn't know.
I get cleaned up for a day. Yeah, but the University of Groningen in the north of Holland came and spoke last year about we're designing new data centers. VMware is going to be at the heart of them. We want to give our research scientists GPUs and TensorFlow to use on them, and they're already documented in a white paper about this. So that's a sort of reference.
Spectacular. So people can
case.
go, if that's it was a recorded session from last year, they can go and watch it.
They can
and
go
then
there. And
maybe get a sneak preview of maybe the types of things that are being talked about at VMworld.
Exactly. And there's a case study written up on that one as well. So that's written by the university folks, actually. Yeah. So it's getting more exciting every year going to VMworld because these new technologies are coming towards us: Kubernetes, machine learning, and there's a heavy overlap between the two, actually. All of you asked me earlier about the ISVs.
Right.
All of the ISVs are beginning to package their software in such a way that Kubernetes can deploy it. Kubernetes apply YAML file, right. To deploy my software. Right. Well, the machine learning ISVs are no different. They're doing exactly that too.
Here's a Helm chart for
Helm chart to deploy. Yeah.
Okay.
Yeah.
That is super. Justin Murray, it's been a great honor to have you serve for these last 12 years at VMware.
Thank you for having me, Eric.
I'm excited you're still here. There are so few people left that I go, oh yeah, I know him. He was here back in the days of Porter walking around the Harry Potter castle. So you're still contributing. You're a great guy. Are you on Twitter? Do you ever Twitter?
I'm on Twitter. It's my full name is John Justin Murray, so it's JOH Justin Murray. I misspelled it and I left it that way. So JOH Justin Murray is where I live on Twitter, and I think I'm most frequently on that blog site.
Right. All right. Go check out his blog. That's awesome. Thanks for coming on the show. Thanks for doing the good work. We'll see you at VMworld, and it's been that is the fastest hour I've ever seen. It's just flew by, and really, really super cool. So
thanks for having me, Eric. Thank you, John.
Fantastic. All right, we got like a minute left. We're at the top of the hour. Tony Foster. It was Memorial Day. Did anybody do any interesting barbecue over the weekend?
I didn't. I talked about the ribs last weekend. I was unable to get those on because of weather.
It was snowing. It was
it
probably snowing, right?
No. It was blowing like crazy. In fact, the wind tried to take my barbecue, but I keep my barbecue chained to the garage so it doesn't go anywhere.
So you lost your whole garage?
Yeah.
Is that what you're saying?
I do have one. It's kind of barbecue-y. I got a barbecue report that I'll jump in and just do for the last minute here. Unagi sauce. So we've been making sushi rolls, just kind of playing with sushi rolls. And we've been trying to make a dragon roll. For about a half a year now, we've been experimenting. You got to do tempura, then you wrap it with rice, then you do the seaweed, then on top of that you put an avocado layer, then you do eel. Right.
Oh, barbecued eel.
Yeah, barbecued eel, right.
Unagi,
unagi, yeah. But the problem is it's never had the flavor of a good dragon roll when you go to a good sushi restaurant. And we finally realized it was unagi sauce. You can get a little jar of unagi sauce at Japanese, food distributors, and that is the magic. That stuff, and it turns out you don't actually need the eel. You don't need anything. You can just have a California roll and put unagi sauce on it, and all of a sudden it has this warm, rich barbecue flavor. So that's my barbecue. I'm going to now try to take that and put it on everything. Peanut butter sandwich. Just put some unagi sauce on it, and you're going to have just an amazing, warm,
magical.
Yummy experience. That stuff is magic.
Yep.
That sounds awesome.
Yep. There you go. So that's the barbecue report at the end of the show. It is Wednesday at the end of May. We're finally getting some summer weather. Hope everybody de-thaws out in the Midwest. And we'll be back again next week with another VMware Communities Roundtable podcast. Until then, everybody have a great week. Thank you very much, John.
Ciao.
Great show. Ciao.